materials in which particles deform plastically without their relative motion. There are many rigid plastic models, including models for incompressible flow of granular materials that lead to singular solutions in the vicinity of maximum friction surfaces. Surface on which the prescribed shear stress attains the maximum possible value admitted by the yield criterion. In particular, the equivalent strain rate, second invariant of the strain rate tensor, follows an inverse square root rule in the vicinity of such surfaces. There S is distance from the surface. The primary goal of the present paper is to explore an effect of plastic compressibility on such asymptotic behavior of solutions. One of the simplest material models that account for plastic compressibility is based on the normality rule and the yield criterion in the form. This is equivalent stress and this is hydrostatic stress. These parameters are prescribed function of porosity. The classical rigid perfectly plastic model is obtained as this condition. The yield surface is represented by these diagrams. If the state of stress compression to the, corresponding to this side, then flow is incompressible. This solution has been already investigated, and therefore it is now of our interest. If the state of stress corresponds to this side, then hydrostatic compression occurs. Therefore, there is no of our interest. This is very special case. The most realistic regime for compressible flow occurs at the singular point. At this point, the state of stress is given by these equations. The problem considered here consists of plane strength compression of plastic materials between two rotating plates. The solution at the initial instant is obtained. Here omega is angular velocity, and this parameter is friction stress. The stress boundary conditions consist of the conditions at the axis of symmetry and friction law. The velocity boundary condition consists of condition at the axis of symmetry, condition at the plate surface, and friction law. This is the another part of friction law. This is condition this is condition satisfied at sticking, and this condition satisfied at sliding. For the future solutions in questions, it is most important to understand the behavior of the radial velocity. For the equivalent strain rate may approach infinity in the vicinity of the friction surface if and only if approaches infinity there. Asymptotic solutions for the boundary value problem is obtained. The final expression for the radial velocity in terms of gamma, you can see here, the C2 is constant of integration and gamma is independent of A. The function gamma is determined by these equations, and constants are determined by here. Analysis of the aforementioned relations show that the regime of sticking occurs in this case. The solution is not singular. In this case, the solution should be obtained for incompressible flow. A typical variation of the radial velocity is shown there. These points corresponds to the friction surface. It seems in this diagram that sticking occurs in the cases considered. In conclusions, the solution obtained is qualitatively different from other rigid plastic solutions. Other analytic rigid plastic solutions for porous materials can help understand if it is a general features of the method. That is all. Thank you for your attention.
Are there any questions? What is the unique feature of the model? Is it the shape of the yield surface?
Can you repeat slowly?
What is it that makes this model different for the rigid plastic behavior?
Oh, it's a compressible material.
Okay, so it's a compressibility.
Yeah.
So it's a compressible plasticity theory. Okay.